My name is Michael and I make weekly videos on all things sports science. In this week's video, we are looking at the report package in R and how sports scientists can use it to simplify their statistical analysis. The report package was designed to help bridge the gap between R summary outputs and best practices to ensure standardization and quality in results reporting. For sports scientists, it can take some of the guesswork out of analyzing the results in things such as correlation coefficients, linear models, logistic regressions, ANOVA, and other tests. For today's video, we're using the soccer performance data that can be found on Kaggle. I'll leave a link in the description below. Looking at correlation coefficients, we can use the core.test function in R. In this example, we're looking at the relationship between RPE and sleep duration in our workout routine dirty data frame. If we run this first line of code here, it returns the results in the console below. It shows us that our Pearson's product moment correlation, it shows us our t-value, our degrees of freedom, and our p-value. It shows us our alternative hypothesis. It shows us the 95% confidence intervals, and it shows us the correlation between RPE and sleep duration. Now, if you're comfortable with statistics, if you're familiar with statistics, analyzing a correlation test is fairly simple. However, if you're not comfortable with statistics, you can use the report function to take the guesswork out of your analysis. So if we assign our correlation test to, in this example, we're calling it A, and then we use the report function of A, it's going to walk us through the analysis of our correlation coefficient test. So in this example, it walks us through the Pearson's product moment correlation between RPE and sleep duration. And it tells us that there's a positive relationship, but that is statistically not significant and that it is a small relationship. And then it gives us our statistics. So it shows us that the R is equal to 0.05. It gives us our 95% confidence intervals, our t-values, our degrees of freedom, and our p-value again. We can also use the report statistics function of A, and that's going to report just those statistics that we just went over. When looking at a t-test, we can compare two different means. In this example, we're going to see if RPE is rated differently for practices versus games. So for that, we can use the t.test function looking at RPE on session type. And when we run that line of code there, it shows us our t-value, degrees of freedom, and our p-value. It shows us again our 95% confidence intervals, and then it shows us our means for games, and then our mean of practice. Again, if you're not familiar with a t-test and how to analyze the results of a t-test, it can feel kind of scary or daunting. We can assign it a variable, in this case b. So we run that line of code there, and then we're going to run the report of b, and it's going to walk us through exactly what is going on in that t-test. So here it shows us that we're running a Welsh 2 sample t-test, looking at the difference of RPE by session type. So that would be game versus practice. It shows us that the effect is positive, statistically significant, and large. And it shows us that the difference is 1.77. Again, it shows us our 95% confidence intervals, our t-value, our degrees of freedom, and our p-value being less than 0.001. A linear model in R can be useful when we're trying to predict the value of one variable based off of another variable. In this example, we're looking at the relationship between distance and RPE. We're going to assign it the letter C, and we usually use the summary function. Now, when we use the summary function in R, it's going to return the intercepts and the RPE, the estimates of both of those, the standard error, the t-values, and the p-values, as well as the residual standard error, the degrees of freedom, the multiple R squared, the adjusted R squared, the F statistics, the degrees of freedom again, and then the p-value at the end. There's a lot of numbers to look at here, and that can be kind of confusing. And so that is why I prefer to use the report function to take the guesswork out of the analysis. So when we run the report function of C, It's going to walk us through everything that we need to know for this linear model. When we run the report function on C, we see that the model explains a statistically significant and substantial proportion of variance where our R squared is equal to 0.67. We can also look right here where it shows us the effect of RPE is statistically significant and positive. And we can do the same thing for multiple linear models. So if we look at a multiple linear model, looking at the relationship between distance and RPE, soreness, and sleep duration, if we were to run the summary function of that multiple linear model, it shows us a lot of different p-values for our model, as well as one final p-value at the bottom. But that can be a little bit daunting, especially when looking at the t-values to try to confirm our results. So when looking at the report function on D, it's going to walk us through each individual variable on distance. So right here we see that the effect of RPE is statistically significant and positive. The effect of soreness is statistically significant and positive, but the effect of sleep duration is statistically non-significant and positive. So even though it's positive, it's statistically non-significant, so we could actually probably drop that out of our multiple linear model. We can use the logistic regression in R to analyze the odds ratio of an injury or illness occurring. The first thing that we have to do is convert our injuries and illness into binomial zeros and ones. Once we've done that, then we can use the GLM function to calculate our logistic regression. If we were to use a summary function on that, it's going to return our estimates, our standard error, z-values, our p-values. It's going to return a null deviance, a residual deviance, and our AIC. That can be extremely confusing if you don't know what you're looking at, but using our report function can make everything more simple. It then walks us through the effects, showing us that the effect of sleep duration is statistically significant and negative. So even though the model is weak, it is still statistically significant. If you found this video useful, please like and subscribe. Thanks.